Welcome, climate-curious listeners. Today we're diving into the world of AI-powered weather wizardry. No crystal balls here, just cutting-edge tech.
That's right, Mark. We're talking about improving climate prediction accuracy. It's like teaching a computer to be a meteorologist, but without the cheesy TV graphics.
Exactly, Tom. We're exploring how AI is revolutionizing climate modeling. It's like giving Mother Nature a supercomputer for a brain. Let's start with the basics. AI-enhanced climate modeling is like giving our current climate models a serious upgrade. Imagine if your smartphone suddenly had the processing power of a NASA supercomputer.
That's a great analogy, Mark. These AI algorithms can process and analyze enormous datasets with unprecedented speed and accuracy. It's like having a million interns working 24/7, but without the coffee breaks.
Exactly. And speaking of coffee, I once tried to predict my coffee consumption using a magic 8-ball. Spoiler alert, it wasn't very accurate. But AI, it's a game changer for climate prediction.
Indeed. One of the most significant advancements is using deep learning algorithms for data assimilation. It's like teaching a computer to be the world's best jigsaw puzzle solver. But instead of puzzle pieces, it's working with satellite data, ground sensor readings, and more.
And let's not forget, this isn't just about predicting if you'll need an umbrella next week. These improvements in climate modeling have huge implications for understanding long-term climate trends and informing policy decisions. Now let's zoom in on another cool aspect of AI in climate modeling. Improved parameterization of subgrid processes. Tom, can you translate that for our listeners who don't speak science-ese?
Sure thing, Mark. Imagine you're trying to paint a detailed landscape on a massive canvas using only a roller brush. That's kind of what traditional climate models do. They work on a global scale, but miss the fine details.
And let me guess, AI is like giving that painter a set of fine-tipped brushes?
Exactly. AI helps bridge the gap between the big picture and the small details. It learns from high-resolution data to create more accurate representations of small-scale processes within global models.
That's fascinating. So it's not just about making broad predictions more accurate, but also about getting more detailed, localized information. It's like going from, it might rain somewhere in the country this month to, there's a 75% chance of rain in your backyard next Tuesday afternoon. Now let's talk about how AI is becoming the Sherlock Holmes of climate data, using its advanced pattern recognition skills to uncover hidden clues in our climate system.
Elementary, my dear Mark? Machine learning algorithms can identify complex relationships and teleconnections in the climate system that might slip past human researchers. It's like having a detective that never sleeps and can analyze millions of clues simultaneously.
Absolutely. This capability has led to the discovery of new climate indices and improved understanding of phenomena like El Niño. It's like AI is helping us read Mother Nature's diary.
That's a great way to put it. And it's not just about understanding the past and present. These insights are crucial for improving our future predictions too.
Right you are, Tom. But of course, with great power comes great responsibility. We need to ensure that these AI-driven predictions align with our physical understanding of the climate system. We can't just blindly trust the machine, no matter how smart it is. You know, Tom, if we were to map this out on a Wardley map, we'd see AI capabilities moving rapidly from the custom-built to the product stage in climate modeling.
That's a great observation, Mark. It really highlights how AI is becoming an integral part of climate science infrastructure. Let's take a moment to map this out using Wardley mapping. Mark, can you walk us through it?
Certainly. If we start by identifying the key components, we'd have climate data at the top as the most visible element, followed by AI algorithms, then computational infrastructure, and finally at the bottom, we'd have climate science knowledge.
I see, and how does this affect the overall strategy for improving climate prediction accuracy?
Well, given the positioning of these elements, we can see that while AI algorithms are moving towards productization, there's still a need for custom development in how we apply them to climate science. This suggests that organizations should focus on building expertise in AI application to climate data. rather than trying to develop AI algorithms from scratch.
Fascinating. So the key takeaway from this map is that the competitive advantage lies in the intersection of AI expertise and climate science knowledge, rather than in raw computational power or data collection.
Now let's look at the draft Wardley map provided in our show notes. It reveals a sophisticated AI-driven climate modeling ecosystem with a clear value chain from data to policy. It's like seeing the blueprint of a climate prediction factory.
Interesting analogy, Mark. And just like in a factory, the map shows we're well positioned in AI and data capabilities. It's as if we've got top-notch machinery, but we might need to work on our quality control processes.
Exactly, Tom. The map highlights significant opportunities in improving transparency and validation. It's like we've built an amazing climate prediction machine, but now we need to make sure everyone understands how it works and trusts its output.
And let's not forget about the future, Mark. The map suggests we should be preparing for next-generation computing technologies. It's like we're using high-end gaming PCs now, but we need to start thinking about quantum computers.
Great point, Tom. So to sum up, our Wardley map is telling us to keep pushing the boundaries with AI while also focusing on transparency and gearing up for the next big leap in computing power. It's an exciting time to be in climate science. Well, folks, we've journeyed through the brave new world of AI-enhanced climate modeling. From data-crunching neural networks to pattern-recognizing algorithms, it's clear that AI is giving our climate predictions a serious upgrade.
Indeed, Mark. It's like we've gone from using a magic 8-ball to predict the weather to having a time machine. Well, almost. Let's not get too carried away.
Right you are, Tom. Remember, listeners, while AI is revolutionizing climate prediction, it's not infallible. Keep questioning, keep learning, and who knows? Maybe you'll be the one to develop the next big AI climate model. Until next time, stay curious and climate conscious.